Welcome to yet another integral, double integral that involves symmetry. Okay, so to solve this integral, um, we first try to see that in denominator we have a symmetric term x root y plus y root x. Now, if this is integral I, now if we try to, we'll see that the limits for x and y are also same. If we try to interchange x and y, we get integral from 0 to 1, integral from 0 to 1, y x root y over y root x plus x root y dy dx. So I've tried to interchange x and y over here, and also the limits, but because these are the same, so they look same. And these two should be equal because the variable is just a dummy variable. Yeah, and so these two should be equal. And since it's the same integral, just replaced x by y and y by x. That doesn't matter actually. Now we can add these two integrals. You can add these two integrals now. 2I is equals to, and now we can again exchange dy dx and dx dy, because over here the limits of integration are the same, so the order doesn't matter, and then we can exchange it, and after exchanging we can add these two integrals, and after just exchanging the order, and if we add these two integrals, we get integral from 0 to 1, integral from 0 to 1, x y root x plus y x root y by y root x plus x root y dy dx, or let's say dx dy. Okay. Now I guess this one is not that hard, huh? Now what you can do is we can just take root xy common, and that gives us over here x root y, and over here y root x, and that's what we have in the denominator too, y root x plus x root y, and then dx dy. Yeah, now we can cancel these two, and then we get 2I equals to integral from 0 to 1, integral from 0 to 1 root xy dx dy. Now we can like separate them. Integral from 0 to 1 root x dx. In the other is also integral from 0 to 1 root y dy, so that's just same. The variables are just dummy variables, so you can square this one, and now this will be 2I is equals to x to the power 3 by 2 by 3 by 2 from 0 to 1 squared. Yeah, so that's 2I equals to when it's 1 we have 2 by 3, when it's 0 squared. So we have now 2I equals to 4 by 9, and then I equals to 4 by 18. So that's our answer. It's 4 by 18, and our integral evaluates to 4 by 18. Yeah, I hope you caught the solution, you understood it quite well, and thanks for watching. Look forward to seeing you in the next video.